Alright, so here's the answer key to this. We've talked about this a couple times. If you have a positive in front and an even degree, your graph looks like that. In the end, it goes up and up. So whether you're going left or right, those are positive infinities. If it's even degree and negative, it goes down and down. So that's why whether you go left or right, you're negative infinity. And the odds are a little harder, but if you remember, regular looks like this. So if it's a positive in front and odd, it goes up to the right, down to the left. Well, here's left, and down forever means negative infinity. And here's right, and up forever means positive. Then the last one looks like this. So to the left is up, to the right is down. And then similarly, we got how do you tell if a function is even, odd, or neither? If it's even, you're symmetric to the y-axis. If it's odd, you're symmetric to the origin. And if you want to do it with algebra, you just plug in a positive version of a number and a negative version of a number. And if they're the exact same answer, it's even. If you plug in a positive and a negative version of a number, they would come out to be just different signs of each other if it's odd. So now we got this question here. Use this, and you're going to show your work you're going to show your algebra work for how they find the x-intercept. So we're not just using a graphing calculator Desmos on this one. You actually have to set it equal to 0 and solve it. Now this is just like, one of those magic question problems where you factor it and you say, what multiplies to make -8 but adds to be -2? It's a 4 and a 2, and the negative sign goes on the 4 because, and the positive goes back there because it's a negative answer. So now this guy factors further because that's difference of squares. This one doesn't factor further, but if I want to find its answers, I could just set it equal to 0, take away 2, square root both sides. When you square root a negative, when you square root a negative, you get plus or minus I radical 2. The I is for the imaginary. And then this gives you 2 answers. This gives you -2, and that gives you 2. So there's my 4 answers. And I expected 4 answers because it was a 4th power. If I graphed it, I would expect 2 real answers and 2 imaginary answers. So when I graph it, and it looks like this, I got my 2 real answers there and there. But you can't see the imaginary, so you have to be able to find it. Y-intercept is easy. You just plug in 0 for x, or you look back here and it's just the constant term. So -8 is my y-intercept. And 1, 2, 3, 4, 5, 6, 7. Well, got to go a little off my graph. Let me put those real points on here. And then end behavior. Well, let's just look at this. It's an even power, and it's a positive number in front. So my graph would look like this, which means as I go left, it goes up to infinity. As I go right, it goes up to infinity. Okay, now determine if it's even, odd, or neither. There's a few ways to figure that out. One is looking at the graph. That is symmetric, so I'll say even. So it's symmetric to the y-axis, or I could plug in a 1 and a -1, and I'll see what comes out, and it'll be the same number. I'll try it out here. Let me pause. And here it is, plugged in for both. They both come out to be the exact same number, which is another way to tell it's even. Or you could common sense it and look, every power is even. Even this guy at the back is x to the 0. So, many ways to do it. Now to find relative max and relative min, basically we're looking for those 2 bottom points, the 2 valleys, and the 1 little hill would be my relative max and min. And this I'd use Desmos or my graphing calculator, so I'm going to take a second and do that real quick. Actually, first, domain, left and right forever. That's true for all of them. Range is a little different. I'm going to have to find my min, because it does have a lowest point. It doesn't have a highest point, so I know it's going to go up to infinity, but I got to find how low it goes. So we need to find those points. Let me take a minute and do that. Alright, so I calculated the relative mins from a graph, and I got them at 1, -9. So it goes down here. Wish my graph was a little bigger. And -1, -9. And my max was right at 0.8. So if I were drawing this graph, down, up. Ooh. There it is. Beautiful graph. All right. Awesome stuff. Okay, then for number 4, here's the 2 features from our notes. Polynomials have exponents that are positive whole numbers and coefficients that are real numbers. So here's an example of one that is a polynomial, because they're all good stuff. Here's an example that is definitely not a polynomial, because you have imaginaries, you have negative exponents, you have square roots. Those are all reasons to rule it out. So that's like the most unpolynomial ever. And I really like this question because it says sketch something that has this end behavior. So you really got to know when you go left, it goes up. And when you go right, it goes up. So I know my graph has got to look like that in the end. And then I have to have zeros here and here. So zeros are x ints. Remember that. So I'm going to go out to 4 and put a dot. I'm going to go to -3 and put a dot. And then I just got to make sure it ends up here and down here. It can do any other crazy stuff you want in the middle. Like you could have it go, woo. But what you can't have it do is you can't have it hit the x-axis again. If it hits the x-axis again, it would have had more zeros. So make sure, I mean, you could just do a parabola if you felt like it, but make sure you don't have other places it crosses there. It's got to end up and up and hit the x-axis only there and there. Okay, so now write a 4th degree polynomial with these zeros. Now we did these problems, these are what I call the backwards problems. So you know if that's an answer, then one of the factors was this. If that's an answer, one of the factors was that. And if this is an answer, one of the factors was that. However, it said 4th power, so I expect 4 of these. And that's where you got to know that these use the buddy system. So imaginaries always come in pairs, and the only difference between them is the sign. So instead of x minus 4i, you're going to have an x plus 4i. And now it's just a foiling festival. So I recommend doing these 2 together and these 2 together and then multiply them together. So I'm going to pause while I do all that math. Alright, so here's the work. I foiled this thing out and it ended up with x squared plus 16 because a bunch of stuff cancels. I foiled this thing out and the middle terms cancel, so it's left with x squared minus 1. And then I had to multiply those together. That's over here. Little foil, 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 and you end up with this. Awesome. Alright. Alright, so this one, just going over some of our factoring abilities here. Difference of squares just turns into 1 with a plus, 1 with a minus. Here's the SOAP. This is one of the 2 SOAPs, right? You do a minus b, then an a squared and a b squared and ab, and you go same, opposite, always positive. So similarly, I wanted to kind of build this one. You got a and b, and then an a squared and a b squared. And the middle is just ab. And then my symbols are same, opposite, always positive. If you have 3 terms, it's the same old guess and check. What multiplies to make c and adds to b. Got to be careful if there's an a term, it doesn't go well. And if there's 4 terms, you got factor by grouping, right? You're going to group them, take out a GCF, all that stuff. Okay. So yeah, always when you have 4 terms, you do factor by grouping. Okay, so let's try these down here. You'll see some are easier, but always take the GCF out first. Huge thing. Most problems have a GCF, like this one. You take out a 4, and it's a different problem. We have 8x cubed minus 1. Now, that doesn't look like much, except it does look kind of like a cubed with a minus sign. If I only could rewrite this as something cubed minus something else cubed, which I can, because 8x cubed is really 2x cubed. So now I can just follow my pattern. Notice I didn't lose my 4 the whole time. I just do my pattern, a 2x and a 1. And then 2x squared would be 4x squared. And 1 squared is still 1. And the middle is 1 times 2x. So now my symbols are SOAP. Same, opposite, always positive. That's as far as that one factors. So that was one of the SOAP problems. Right? This one is going to be more like the one we already did. So I'm going to pause that and just do it. So yeah, this one, you say what multiplies to make negative 24 and adds to be 2. And it was 6 and 4. The negative goes in the 4. This one factors further because it's a difference of squares. That one doesn't factor further because 6, well, isn't a perfect square, and that's a plus sign. Then you get to letter C, and you get a problem with 4 terms. So you have to group the first 2, and I always tell people to make that a plus sign, plus a negative 7, and group the last 2. And then you say, what's common to those 2? I can take out an x squared. If I take out an x squared from there, I get x minus 3. Now, what's common to these 2? A negative 7. If I take out a negative 7, what's left is x minus 3. If you took out a positive 7, you would not get what you wanted. And then, since they both have one of these, that's one of your end terms. And what goes in the other bracket is the leftovers, x squared minus 7. Now, I would factor that further if it wasn't a 7 there. If it was a 9 or 16, I'd keep going. All right, 2 questions here. 1, how do you solve it after factoring? You set each factor to 0 and solve. And 2, how do you know how many zeros? The degree is the number of zeros. Then we get down here, adding, subtracting, multiplying, dividing. I'm just going to kind of do that and have you look at it. All right, so I will do the synthetic division one. First, you have to notice if they give you a factor, you change the sign. And then when you write your coefficients down, make sure you check if there are any missing, because you need a 0 placeholder. This problem doesn't need a 0 placeholder, so you're good. And then we drop down the 2, you multiply and add, and multiply and add. What's that, 15? You multiply, and you add, and then you reinterpret your answer, okay? Because I divided out a x minus 3, and it started out as x cubed, so this is going to be how many x squareds I have, minus 10x, plus 15, and this is remainder of negative 41, and technically it's still over x plus 3. It's going to be your answer there. Alright, so for the last couple questions, finding max and mins, just use graphing calc or Desmos. And then when we go after this problem, this is the one we did the other day, if you see a power of 4, I expect there to be 4 zeros because the degree is 4. So we're going to use our graphing calculator to find the real zeros. If you look at your graphing calculator, you will see it looks like it hits at 2 and 4. So I'm going to do a little synthetic division down here to take out 2 and 4. Okay, so the first one I did, I divided a 2 out with synthetic division. I could have used the other one, but what that did was show me 2 is in fact where it hits the x-axis, and now I'm going to use a 4 to synthetically divide, but I don't want to do it to the original problem up here. That's where I got those coefficients. I want to do it to what's left over, these answers. So I'm going to do that with a 4 outside of it. I'll pause it while I do that. Alright, so I took a 4 out also with synthetic division, and I get a 1, 0, and a 16. Another remainder 0 when I did it to that. And we have to retranslate this into what it means. That means if I started with x to the 4th, by the time I did the first synthetic division, it was x squared, and now this is, x to the 3rd. Now it's x squared here. So I translate that to x squared plus 16. I move the 16 over, take the square root. It's plus or minus 4i. I also had my 2 real answers from before. So I got 2 real from the graph, and I got 2 imaginary from me solving it once it was once I had taken out all the real answers. So a total of 2 real, 2 imaginary. I got the 4 answers I was looking for, so I know I'm done. Alright, that's it. Study up.